So let's look at example 1 here. It says find the general solution. When they're saying general solution, to you that should trigger the idea that we need to add plus c of the differential equation dy dx equals 2. So what are they saying here? They're saying, what do you take the derivative of? I'm going to write this down. What do you take the derivative of and get to? Okay, so what can we take the derivative of and get to? So you might start thinking about that, and we might notice that the derivative with respect to x of 2x equals 2. So that means you take the derivative of 2x, you get 2. This is the what I'm calling the parent function, which they refer to as capital F of x. So you take the derivative of 2x to get 2. But remember, this is not unique. This is a single answer. There are always an infinite number of answers. What could the answer be? Well, the answer would be what we got, which was 2x. Sorry, let me use black. It would be 2x, but then we need to generalize it by adding the plus c. In other words, it could be 2x plus or minus any constant. For instance, the derivative of 2x plus 5 is just 2. The derivative of 2x minus 6 is just 2. So the general answer, which is how we have to answer these, the general solution to this differential equation would be 2x plus c. Again, the differential equation is saying, what do you take the derivative of and get to? And the answer is 2x plus any constant. So that's how you have to understand these. Again, we're working backwards. We're starting with the answer, and we need to come up with a function where we take the derivative and get the answer. So backwards from what we're doing. It says when solving the differential equation of the form dy dx equals f of x, notice it's lowercase f of x, it is convenient to write the equivalent differential equation of the form dy equals f of x dx. dy equals f of x dx. The operation of finding all solutions of this equation is called anti-differentiation or indefinite integration. So working backwards, when we work backwards, so going forwards we've done differentiation. Going backwards it's called anti-differentiation. Another way they call it is indefinite integration. And then we're going to use this new sign, and it's this long, thin S-looking symbol that's called an integrand or an integral symbol. Okay, so that's so you just call it the integral, and it says the general solution is denoted by. So how do you find the answer? The function, the answer is y. You say is the integral, or this is called the indefinite integral to be more specific. We could also call it the antiderivative of f of x with respect to x. What do we know the answer is? Well, it's the parent function, but remember you have to have plus c. The parent function being the antiderivative. So in this case, what we just found, looking at the previous problem, what we just found is the antiderivative of 2 with respect to x. So we're stating what our variable is. Our variable is going to be equal to x. So you're saying, what do you take the derivative of to get 2? The answer was 2x plus c. That's what we just figured out on the previous problem. So that's how we would write it. So one way to denote it is by looking at it as a differential equation like they did in the previous problem, dy dx equals 2. And one way to use it is with this integral notation, which is just that integral symbol saying find the antiderivative or find the parent function of 2. What function do I take the derivative of to get 2? It says the expression, the integral of f of x dx, is read as the antiderivative of f with respect to x. So the differential dx serves to identify x as the variable of integration. So if we said like dt, all that would mean is instead of 2x plus c, we would have had 2t plus c. It's just designating your variable, okay? The term indefinite integral is a synonym for antiderivative. So you might hear me say antiderivative of f of x. You might hear me say indefinite integral of f of x. It means the exact same thing. So, exploration, finding antiderivatives. It says for each derivative, describe the original function f. So here what we're saying is, what function do I take the derivative of and get 2x? So what can I take the derivative of and get 2x? And hopefully you can think of the answer is x squared, right? How do we know it's right? Because the derivative with respect to x of x squared is 2x. Those things must match, okay? When you take the derivative of your answer, you must have the original problem. It's really nice with antiderivatives because now we can actually check our answer. So we know the answer is x squared. If you take the derivative of x squared, we get 2x. However, there is one thing we need to be careful about. We always need to remember that this is one answer, but really there are an infinite number of answers. So to cover all of the answers, all we do every single time is add that plus c. You've got to remember the plus c. All right? Let's look at the next one right here. We're finding the antiderivative of. So what do we take the derivative of and get x? What do we take the derivative of and get x? Well, I know how to get a 2x, right? If I take the derivative of x squared, I get 2x. So how could I get just an x? So I know it has to have an x squared in it, right? But the derivative of that is 2x. And I need to get rid of that 2 in front. So how do I get rid of that 2 in front? Well, instead of multiplying by 2, let's do the opposite, right? Let's divide by 2. So consider taking the derivative of x squared over 2. What would happen if I took the derivative of x squared over 2? Well, that would be 2x over 2, which would be simply x, right? So again, I know I'm correct because if I take the derivative with respect to x of x squared over 2, I would have 2x over 2, which is just x, which is the original problem. So I know my answer is correct here. Except this is only one answer, and I need an infinite amount of answers. How do I make it infinite? I simply add plus c. I could add or subtract any constant that I wanted onto that. Okay? Let's look at part C here. Part C. What do I take the derivative of and get x squared? So what do I take the derivative of and get x squared? Okay. Well, I don't know if this is coming to you yet, but if I take the derivative of x cubed, I get 3x squared. So with derivatives, when I took the derivative, I went 1 power down, right? With antiderivatives, I need to go 1 power up. So I know if I take the derivative of x cubed, I get 3x squared, but I want just x squared. So how do I get rid of that 3x squared? Well, just like the previous one I divided by 2, here I would divide by 3. So my guess is the answer is x cubed over 3. Well, let's see if we're right. Let's check it by taking the derivative with respect to x of x cubed over 3. Well, that would be 3x squared over 3, which would simply be x squared. That's exactly what we wanted because that's what the problem started with. So what would our answer be? It'd be x cubed over 3 plus c. Let's keep on going. How about this? F prime of x equals 1 over x squared. What do I take the derivative of to get 1 over x squared? Or if it helps you to see it as, what do I take the derivative of to get x to the negative 2? So what's the antiderivative of x to the negative 2 with respect to x? Well, again, if you've noticed from the previous problem, if I wanted a square, I had to go 1 power up. So if I want a power of negative 2, I have to go 1 power up. Now, this might mess you up because you might think 1 power up is negative 3, but it's not. 1 power up literally means add 1. So I know my answer would have to be something like x to the negative 1, right? X to the negative 1, well, let's think about that. When I take the derivative with respect to x of x to the negative 1, wouldn't I get negative 1 x to the negative 2? Which is negative 1 over x squared? but I wanted positive 1 over x squared. So how do I get positive 1 over x squared? Well, all I have to do is take that and divide it by negative 1 or multiply it by negative 1. It's the same thing, right? Dividing and multiplying by negative 1. So think about taking the derivative of negative x to the negative 1. Well, then that would be negative 1x to the negative 2, which would be a positive 1 over x squared. So I was off by a negative. What do? I multiply or divide it by negative 1. That's perfectly fine. So what am I saying, which by the way, this is the right answer because that's what I wanted. So what am I saying the answer is? I'm saying the answer is negative x to the negative 1. Well, I can write that a lot nicer, can't I? Can I write that as negative 1 over x? So the derivative, what I'm saying, the derivative of negative 1 over x, the derivative of negative 1 over x would be 1 over x squared. And that's correct. But this is only one answer, and again, I need an infinite number of answers. So I have to come in here and I have to add c. Let's come in here. What do I take the derivative of to get 1 over x cubed? Well, this is going to be a lot like the last one. Let's think about this. This is x to the negative 3. So what we're saying is, what do I take the derivative of and get x to the negative 3? Okay? Well, if you remember, we have to go 1 power higher. So we know that it has to be x to the negative 2, but then I'm going to have to be careful with that. So I'm going to do some side math here. Let's think about it. What's the derivative of x to the negative 2 directly? Well, that would be negative 2x to the negative 3. So what am I off by? I need to get rid of that negative 2. So how do I get rid of that negative 2? I just divide by negative 2. Divide both sides by negative 2. So when I do that, I'd have x to the negative 3, which is 1 over x cubed, as desired. Okay? So, what do I really have? What have I taken the derivative of? Well, let's clean it up. X to the negative 2 over 2, isn't that negative 1 over 2x squared? Negative 1 over 2x squared, if I clean that up and write it in proper form. So what I'm saying the answer is negative 1 over 2x squared. Again, that's a single answer. I need all of my answers, so I have to do plus c here. Okay, so I'm going to come in here and I'm going to make sure that I haven't finished writing everything. So this was divided by, all I did was I went back in and I realized that I knew that it had to be x to the negative 2, but I didn't compensate for the answer there. I did the same thing. No, I did it right over here. Okay, I put a negative sign right there, so we're good to go. Okay, let's look at f here. What do I take the derivative of to get cosine of x with respect to x? What do I take the derivative of to get cosine of x with respect to x? And probably a lot of you immediately or nearly immediately thought about the answer sine of x. What's the issue with that? That's only one answer. We need an infinite number of answers, so we have to add plus c here. How do we know we're right? We'll take the derivative of your answer. What's the derivative of sine of x? And the answer is cosine of x. So I know my answer is correct. I have the right answer. So that's what antiderivatives are. All we're doing is saying what, or indefinite integral, same thing. What do I take the derivative of to get this answer? And again, it seems to me like when we took a derivative, we had to go a power down. So when we take an antiderivative, we have to go a power up.